The broadcast is now starting. All attendees are in listen-only mode.
Hi, everyone, and welcome to our webinar today. My name is Tanya, and I'm the marketing manager over here at Strucsoft Solutions, part of the Great Tech Group. So today, our CMS expert, Mahbub Rahman, will be showing our CMS for Inventor plugin. So this plugin accurately creates DSTV files for CNC machines that produce structural steel, bent parts, and hot-rolled sections. Using this software, users are able to quickly convert any native Inventor part file, as well as STP, STEP, IGS files, all directly within the Inventor platform itself. So just before we get going, I'd like to remind everyone that at the end of the webinar, we'll be taking a couple of live questions. In order to be selected, please press the raise hand button on the dashboard. Just please also make sure that your mic is working correctly. If you'd prefer, you can also ask questions throughout the webinar by typing into the questions tab of the GoToWebinar dashboard. All right, that's it for me. I'm going to hand off to Mahbub now.
Thanks so much, Dania. Once again, gentlemen, welcome to our webinar for CMS for your Inventor platform. I've been helping my CMS clients worldwide for the last 7 years, and we have made a lot of changes on the software. So today would be a good time that we can show you some new stuff that we have done, and also the total workflow to produce your Nc1 file from your parts, Inventor parts, and also from your Autodesk, your assembly files. So let's start. So what I'll do, I'll go through my few slides here, and then we'll jump in directly to the Inventor platform. I'll work with a couple of examples that I have. I'll show you the process in the Inventor platform directly. Okay, so let's start there. Okay. So let's start with what kind of product that we offer with our CMS. So CMS can be used on your Inventor platform, your SolidWorks, and your AutoCAD, and also in MBS. So, but we are totally focusing on the Inventor platform today. Additionally, we have a solution that we call CMS Standard that can manipulate, clean up your DSTV files as well. So, if you create anything from your Tekla and SDS2, and then you're having tough time cleaning up your edge preparation details, like the bevel details, this is where you can, edit and clean those stuff and add new stuff as well. So, so for post-processing, you can also use CMS Standard also with your Inventor, CMS for Inventor solution, right? So, so what is the CMS for Inventor? So the CMS for Inventor reads your native Inventor parts, and it can also read your non-native parts, so Inventor parts, so like your step files, your IGS and set files, that kind of stuff. So the file extension that we have on our software is .nc1. So you probably know that we might have .nc and .nc1 both file extensions. So it's not a big difference in terms of when it comes to your CNC machines. So as long as your machine can read a DSTV standard file, so then that the machine will not have any issues whatsoever with our Nc1 files, right? So we strictly follow that DSTV standard, our Nc1 files. Okay, so for the folks who are new in this area, like and have no exposure to the Nc1 file, the DSTV standard. So for you guys, just a quick view on this is you're gonna have your DSTV file for each of your parts. All it does, it describes your operations. So you're going to have a couple of blocks of your operations on the DSTV file. So for example, as you see on the screen, AK will be representing your external cuts, anything to do with the border cuts, any opening that will be with an IK block, your slots and holes will show up as a BO. Your text stenciling, stamping will come as an SI block. Your scribing, marking contents will come as a KO block. And if you have any kind of bending operations, so let's say if you're working with sheet metals and you have bent profiles, then it will come as a KA block, right? Though the DSTV file itself has 25 lines of header data. So some of the header data that we will be able to map from your iProperties. So all those blocks and header data, I'll give you an example as well when we start on our Inventor platform. Okay. So additionally, additional advantage on the software is, like, you know, it's a complete plugin on your Inventor platform, right? So you don't have any system requirement for the software. You know, as long as you can run Inventor, it's going to be okay with our CMS. You can keep your current access control for your Inventor users. You know, any vault access issues, no, it doesn't impact anything. The license works exactly similar to your Inventor platform. So it's a web-based licensing, so you don't have to need any kind of server or something if you go ahead with our floating license options. So as you see over here, there's a couple of sample machines that our clients are running with our Nc1 file. So the bottom line is, as long as your machine runs, can read DSTV standard, DSTV files, that, you know, there will be no compatibility issues whatsoever. So it's gonna right away you just you know, get this Nc1 file from our software and plug it in on your machine to your USB or from directly from your server. Any way that you handle your Nc1 file, you know, the machine will pick it up and you will be able to manufacture that right away from there. Okay, so without further ado, let's jump into our Inventor platform and work on a few samples here. So first, the thing that I just pulled up an unequal angle over here, but I'm just gonna run quickly to produce that Nc1 file, just to give you guys some idea about the DSTV files, how it looks like for the fellow who are as a new stuff for them. Okay, so if I just click on there, as you see right away, it creates my Nc1 file, right? So the first on my slides, I mentioned that the software, the DSTV has 25 lines of header data. So those are the 25 lines here. So it starts with an ST command and ends with an EN command, right? So this is your AK is your external boundaries, your external boundary description. So if you have, you know, if you are working on an angle, so you have two faces. So you have your bottom flange and you have your web. So you get two blocks. And the IK is here for your internal cuts. So you see that there is an IK, so one on your bottom flange over here, and over the other one is IK is on your front web, right? So then you have your drills. So you have one drill on your web, so as you see over here, and then you have you know, 4 drills on your front web. So this is how it typically look like a DSTV file. So pretty straightforward. And then, you know, from there, once you get used to your DSTV file, right? So you can easily relate that the translation was really right and correct, right? So one of the thing that we have on those 5 lines here, so that we call DSTV header data, within those 5 lines, we can map your details from your iProperties. So it might be dependent on your machine need, or it could be like something that you want to do for bookkeeping purposes as well, right? So before going to all this stuff to run your Nc1 file, the first thing that you have to do is set your orientation, right? So I just gave you an example how a DSTV file look like. So now, before I go to create an Nc1 file, I just want to talk about what's the modeling requirement that we have for creating an Nc1 file, right? So the only thing that you need to create an Nc1 file from a part, that only requirement is modeling wise, is that the part have to be a single body part, right? And then you know, from there you can create Nc1 file. Okay, so let's talk about you know, what required need to be done on the other side of the model. I mean, to create Nc1 file, you know, do more automation, right? So one of the things that we do look for in the model in your iProperties could be your shape size information. So I'm just going to go to the settings and kind of like, you know, give you a quick review what that setting does. Okay, so if you just go to our input output settings, so it allows you to, you know, save how you want to save your parts. You know, either you can grab your part number from your iProperties, or I can just grab that document name that you have on your file, and I can just save based on those selection. I can save the name of the Nc1 file. So this is your naming convention, right? So how do you want to save those files? And then you can also dictate where do you want to save your Nc1 file. So as you see over here, I'll be saving all my Nc1 file over here today. So as you see, the first one that I clicked for that unequal angle, that's been saved over here because this is where I'm saving that. So you can just save it to your server directly, or if you want to transport it to an USB key, you can select that and you can save your files over there as well. So the last thing that I want to talk on the settings is my property links. As I said, that some of the lines that I can map to from your iProperties, right, for those lines. So this is where I can do that. So let's say, for example, I want to create, part number on my first line, and on my third line, for example, I want the length information. So it actually lists all the iProperties that's available on the single part, right? So if you just drag it, I mean, go ups and down, and you can select the thing that you want. So let's say instead of project, I want the length of the part to be shown on those lines. So I can just drag and drop it, right? So again, those are the settings that you have to do just only once. And these 5 lines is not necessarily mandatory. It could be your mission need, or this is something that you want to follow, right? But for automation, the requirement that we look for is the shape size information. So if you want to create your Nc1 file quickly from your model, and you don't want to bother getting your sizes from our shape size library, or you want to add it quickly from here, okay? So this is what we'll look for. It could be in the stock number, description, anywhere. But for what I'm doing, I'm keeping all my shape size information on my stock number properties. Okay, so this is where I did, as I said, like you can just select anything that you want, and you can just just drag and drop it, right? So you can find any properties here and drag and drop it, but I'm reading it from stock number, right? So once this is that one-time setting is done, all I have to do is create an Nc1 file from here, right? So you come here, you open that file, and then all you just do, you go back to your CMS tab and hit on Generate DSTV. So once you do that, I'm waiting for a response. As you see over here, if I go back to my settings again and just try to relate that, see that over here, this is my part number. Going back to the settings again. And the third line that you see is a 72 inches long part. So it's coming from that length here. So everything that you over here, if I don't have any data, as you see on the revision number, I didn't have any data, so it came as an NA. So again, this is something that you want to figure out how it works with your machine, or how you want to go ahead and do that for you. Okay, so this is straightforward to create an Nc1 file from a model. Okay, now let's talk about what's in it in this model, right? So as you see on this example, I had a coping here, I had some drills, I had a slot, and I had a miter details, and what else? So as you see over here, I can also bring marking content as well. And if I go to the modeling section here, as you see, this is an emboss feature. So this is for you're stamping your content. If you put a specific stamping, we can read it through emboss feature. So if you want to do that, don't want to do that through emboss feature. So if you go to your settings and if you click on stamping, we have a different way of doing stuff as well. So let's say, for example, you want to stamp your part with your part number, for example. Okay, and you want to put it on a specific on a default position, right? So you can stamp that for example, I can just use property links also. Okay, so if I go back to my property link, as you see for the part stamping, I'm grabbing the part number, for example, right? So I can grab that detail and put it on a default position that I want. Okay, so let's say, for example, over here, anything that I have, I'm going to put it on my front web, and from the top left corner, I'm putting that on an X offset of 20 millimeter and Y offset of 20 millimeter. So I'm just putting those values in millimeter, just to be kind of easy for me, because even though you are working on an imperial shape, at the end of the day, all the value that you see on your DSTV is in millimeter. It's a metric. So no worries on this, because your machine, your Nc1 reader on the machine knows that. There is no conversion involved for you to make it compatible for your imperial shape. So the machine itself, the CNC machine itself, will do that for you. Okay, so I'm just going to, if you just use that, so what it does, instead of putting it on an emboss feature, it will just go ahead and read your part number properties and grab the details from there and put it on a default positioning. Okay. So this is about it for the stamping. So let's say, and then for example, as I said, if you want to add more details, for example, so let's say you want to scribe, you want to put a marking content. Remember that I talked about like the software, our software can read also marking detail. Okay, so let's say you want to put a marking detail to the channel over here. Okay, so what we did actually, because you might have some unused sketches, but the software needs some clues that which sketches that you want to bring as a content for your marking or scribing lines, right? And the same goes for your pop marks as well. So let's say in some cases, the people don't want to use the lines. So what they want to use the pop marks for weldment indicator, like where you're going to be welding your other parts, right? So I can just handle both all together. So let's say if I want those lines as my scribe line, so I just select that that line, and I just format that for me. Okay, so from there, it can distinguish, the software can know like, okay, I don't have to bring those construction lines as a scribe line. I'm just gonna bring this line as a scribe line only. So the same goes for your pop marks as well. So you select your pop marks and you format that, right? Again, those are the steps that you need if your machine does it. If your machine does the scribing and pop marks, then you do that. If you don't want to do that, you don't have to format that, right? So you just open your part and click on DSTV and it will be, the Nc1 file will be ready to go, right? So what we did over here, additionally, as I said, we just formatted those lines for scribing and formatted those points for pop marks. So, and now as you take a look here, there is no KO block and there is no indication of a pop marks. Okay, so all I do after that, I rerun it, and I'm expecting that my Nc1 file will be updated. So as you see, if I just scroll down here, so these are the new additional component that has been added here. So this is the first, these are KO blocks, which are coming for those 3 lines. So as you see, I have 3 lines here. So I have 3 blocks of KO, indicating the marking lines. So if I go back to my pop marks over here, so as you see, there's a small tiny M here. So that indicates your pop marks. So I had 4 pop marks here. So that's the reason why I have 4 entry line here. So if I go back to the text stenciling details again, so as you see, I have 2 text stenciling line here. Again, remember that I had the emboss feature. So it's the first line, it's grabbing from there. And the second line, it's grabbing from my default settings that I just added over here for that stamping here, right? I'm putting it on a default 20 millimeter, and the default height is 10 millimeter, and it grabs my name of the parts, which is the part number, right? So, and then it put it there. So this is how you can automate your text stenciling, stamping, your marking content, and also your pop marks. Okay. So we offer a tool that we call Nc1 Viewer. Okay, so if you use that's a free tool that we offer. If you just go to our website and you can download it from there. So over here, all you have to do, you open that, and all you do is, you just go. Remember, gentlemen, we are saving all the content over here, right? So if I just copy that path, just to see the Nc1 file I just created, I'm just copy and pasting that. So that's the first angle that we created, and this is the beam that we are working with. So as you see over here, so we're gonna have two stamping. So that's the default stamping that we had, right? And the other stamping that coming is actually the stamping that we did from the emboss feature. Okay, and this is your four what do you call it? The pop marks there. See that? And then those are the blue line that you see. Those are your KO content, the marking content. So you can this tool can be used to verify your Nc1 file visually, right? So what the process would be, you create your Nc1 file. Once you're done with creating your Nc1 file, you come to that viewer and you open your Nc1 files and visually do the quick quality assurance thing, right? So one of the things also you might have noticed on this viewer here, I mean on the part DST viewer, is this one here. See that, this angle? So the software will be also calculating your miter cut here as well. So if you have a saw tool, like let's say you have a Workman machine, and the Workman machine does read those angles from there, so you know the machine knows from right away there that I have a 45-degree miter cut there as well. Okay, so I'm just going to move on and try to work on a different example. So it's just the same thing. You know, this is a sample channel. As you see, I have a miter there, some cuts there, and a bunch of drills here and there. So all I do is the same thing. If I go to my CMS set, my properties, just to let you guys know that I have the stock number details, so I'm reading that data from there, right? So if you don't have it, you know, the software comes with a catalog. You know, you can we have different country standard, as you see over here. We have different profile types. You can go to angles. You can go to your HSS, and you can find the stuff that you're looking for, right? So if you don't have it, that information is not there. So you can always use that information from here as well. Okay, or you can quickly add your sizes if you don't have it on your properties, right? So we're going to show those two examples on our coming examples. Okay, so let's as you see that, like, I have all the details on my iProperties. All I have to do, I have to open that part and run my DSTV. That's it, and within seconds I have the Nc1 file. So I get all the details. As you see, it's bringing my SI block, which is the text stenciling, right? So it grabs all the details there. What I'm going to do, I'm going to turn off my stamping because I don't want my stamping. So I'm going to turn it off. So if you want to change anything and if you rerun it, so it just the software will override it. Okay. So you just created an Nc1 file from your channel. So if you just go back to your viewer and try to see that. So I'm just going to show you that quickly again. So that's the channel that we just created. As you see, if I just zoom in here, so that, as you see, I was a clean cut there, clean miter cut, and all the drills, if I go to the front web view, all the drills were captured with just only one single click, right? The process is identical for, if you have anything to do with your opening. So as you see, this is a BIM with a bunch of opening, and the process is similar again. So you just run it, and you will see that you have a bunch of IK blocks here, so which is indicating your internal cuts. So again, if I go back to my viewer and try to verify that, obviously you're not going to go one by one, right? So once you are done processing your every content in processing them from your Inventor platform, you come over here and visually verify that. And if there's any issues, you go back to your Inventor model and try to fix it from there, right? So as you see over here, I was able to grab all those opening with one single shot, right? So pretty straightforward, right? So the process is also same for your all the angles as well. So this is an angle, as you see, the same drill again. You open it, you click on this, and voila, your Nc1 file is ready to go. This process is similar for your tubes, as you see over here. I have, if I go to my right views here, so as you see, I have a miter over here, and few drills here and there, right? So the process again, I'm just going to run that, and within less than a second, you will have your Nc1 file good to go. So as you see, I have 4 AK block here, so which is your top flange, your bottom flange, your front web, and your back web, right? And then your operation on the bottom flange here, on the web, and on the back web here, right? So let's verify that again one more time. Same drill, just to see the same stuff that's been done correctly. So as you see, if I just zoom in here, as you see, that's my miter cut there, clean cut here, and that's the angle that we created also, right? Okay, so that covers my process for single parts, right? When you work on a part level. So what happens, if you want to work on an assembly level, right? So so let me go ahead and go to my assembly that I have open here. So as you see, this is a very small assembly here. The software comes with a warning as well, as it gives you a clue if something is missing here, right? And from there you also can can realize if there is any issue, especially like, if you're missing any information regarding your ship size, if the software cannot match the thing with the library, the software will give you a clue all the time. So one of the things I also want to show you guys is this. So the software comes with a library. So you can, this is the library this comes as a CSV file, so it comes with the library. So if you have to play with that library, you can always do that, right? So let's say you want to edit that, you want to add new members, you can come to the CSV file over here. As you see, it's a pretty straightforward thing. All it does is it talks about the profile height, width, and flange thickness and web thickness, and the fillet radius. You can ignore that. We don't play that much with that number. Only those are the critical numbers. So as long as if you have a custom sizes, for example, we have a couple of CMS users who have their own library. So they just they created their own shape profile sizes and stuff. We can always incorporate them on our CSV library, right? Additionally, if you don't want to do that from here, I'm just going to say don't save it. I'm going to go back to a part level file and just click on this that shape catalog here and click on edit. So the software, as you see over here, you can create your own sizes from this UI even. So all you do, you give them a shape size. As you see over here, I just even create an what do you call it? It's a DIN library that I use, but the size name was in, it's in, I think it's Russian name. Anyhow, so you can give your, you can edit it, you can even update it. So let's say, for example, I don't want to update it. So I just say update entry. So this thing will be updated, and you can add new member as well. So let's say, for example, say you say test, for example, and I want something, 250, for example, I'm doing in millimeter, not necessarily you have to do that. So if you do anything in an imperial, you just uncheck this one. So those values will be taken as inches value, right? So for the metric one, imperial one, sorry. So I'll keep that checked all the time. So add new. So as you see, I have it over here as well. So it's, something, as I said, you can play with from that CSV files, or you can just add it through here. So it covers, so that means the software can cover both your standard sizes and also your custom sizes. Remember, we can only read your standard profile types, not the profile size. So we can do any size you want, but you have to make sure that the model is a standard model. So which is, it's a standard I-beam. I mean, the profile type, I'm talking about the type, not the size. It could be any size, but the type have to be standard one. So we can only at this point, we can read your channel, your angle, your plates, your I-beam, your T profiles, your round bars, your round shapes, the pipes, and also your tubes. So these are profile code that we support at this point. Okay. So now let's go back to our assemblies here. So what need to be done to kind of batch process everything all together? I want to process everything, right? So what we look for is, again, that you have to have your shape size information on your part. So if you don't have it, we'll not able to process them, because the software, what it does, it looks for that. Creating adding your shape sizes is easier on the part level, not on your assembly level. So you have to make sure that you have that information ready there. So as long as you have that shape size information there in all of your part level, then creating Nc1 file is just one single click. So I'm just going to show you all the parts that associated to that here. So as you see, like, this whole assembly has actually 15 unique parts, right? So what I'm doing right now, if I run that entire assembly, I'm expecting to see 15 Nc1 file in one single shot, right? So if I run it here, so this is what I'm expecting. So if I run it, wait for a few seconds to, the software also shows you a process progress report as well. So right away, it will create a folder on that target location. It will grab the name of your assembly, and on that folder, it will put all this Nc1 file as per either your document name. So I am working on selecting on the document name. As you see, I'm just grabbing those names from the document and just putting it as the Nc1 file. And additionally, it gives you a conversion report as well. Okay, so those are warning. As you see, this pops up here as well. So if some part fails, it will say that, like, that part PL02 was not were not converted. So you know that that it failed. But as you see, that I was able to actually grab all those 15 parts, right? So if I just grab that path just to verify those quickly with my viewer, I can just go over here and put it the directory, and I can just go ahead and one by one and visually verify that. As you see, those were angles was grabbed correctly. This is a beam that with miters, with some copes here and there. So as you see, that part had some drills. So, as you see, like, creating Nc1 file from an assembly is very easy as long as your models are what we're looking for. So as I said, like, we have to have the shape size information, and especially like for the naming, either well, definitely when you have the unique name on your part, then we can easily grab it. So if you don't have, and we can also grab the part number as well from there. So it's your choice how you want to go ahead and do that, right? So when you come to the assemblies, as you see, we have 3 options actually. So I just showed you the processing the entire one. So this is easy for, like, if like, you need all the members, but sometimes you might want to do work on selected members or tagging members. So for example, I'm just taking that one here. So as you see, this is a very small assemblies, and I have two beams here and 2 channels here. Okay, so you know what, like, let's say for a big assemblies, and you want to process your channel first, right? So what you can do, you can tag your channels. Consider about a big assembly, not this small one. So the tagging will be an option. Oh, no tagging was found because I didn't tag it first. So I can just select them, and I can tag it. So I can tag this part, right? So once this is, you can just, kind of go ahead and find your parts or channels and tag them. And once those tagging is done, you can just, kind of create Nc1 file for those tagged item. So as you see, for some reason, I see that one of the Nc1 file has been failed. Maybe I can just, there was no clue. Let me see what's going on there. Or maybe they're the same part being called twice. My intuition is they are both identical part. Let me open that. So is this one there? Maybe they have the same part number, so that's why it's just bringing only one part, right? So that's why I mentioned, like, when you have the part number, you make sure that you have the unique part number on your parts. Okay, so that assembly is an easy demonstration that, like, that you can also tag members, and from tagging you can create Nc1 file from there, right? So there's another example that helps. If you have an assembly that is not, you're missing some kind of reference parts are being missed, but you have a few members access from there, you can just tag. I can kind of select the members that you want to convert to. So I can just quickly select the members that I want to convert to Nc1. So selecting members and creating Nc1 file from there is also possible. So this is what I'm trying to show you here. So let me select here and there, and it's actually I'm selecting almost everything. So once this is done, I can just go ahead and select, like, give me the Nc1 file for all those selected members. So once you run it, the software, again, see that over here, it gives you the process conversion progress as well. So it's that 67%, 71% has been converted. So it's once this is done, yeah, definitely I'm missing something here. So yeah, something is not right here. So let me go ahead and get it. So see that the sizes, let me go back to my settings and figure out what's the wrong here. I'm going to go back to the part number. Maybe, like, I don't have the document names are not giving me the right information. So I'm just going to run it again with the document name and rerun it. Oh. Sorry, bear with me. I'm going to go ahead and select quickly over here and there. Come on. Doing it quickly. Those parts. Again, so when you select members, so you have to make sure that I have access to the members directly. So I cannot work on sub-assemblies. So as you see, this is a sub-assembly here, right? So I have to go to that sub-assemblies and work from there. I cannot run my sub-assembly from an assembly level, okay? So let me run it. The selected ones, hopefully that fixes my problem. Waiting for the response and see how it goes. 91%. Yep, there you go. Yeah, this is it. So, I have, because it was not able to grab those names correctly, so that's why it couldn't give me the information that was been missed. So as you see, I'm now grabbing all the details from there. So, this is a good example also that how you can use your CMS to create Nc1 file on a selected member. So if I just go back here, as you see, I was able to grab those copes and drills very easily. So with just one single click, right? So that viewer is also very helpful, like to kindly quickly verify your Nc1 file, that whether anything is coming out of the boundary, and you can quickly notify. Identify if there is any issues on those parts. Okay, so that pretty much it for the assembly side. Now I want to talk a bit about the bending operation. If you have any bending need to be done, or you have sheet metals, right? So for creating Nc1 file from sheet metals or any bended profile is very straightforward. Again, it just all you have to do is you just open your part and create Nc1 file directly from your from this generate part DSTV command. Okay, so once you click on that, the software is expected to grab it. Again, at the end of the day, even though as you see that has been a beam has been created from a sheet metal. So as you see, it grabbed all the drills. So if I just go back to my my sheet metal features and try to see the pattern, as you see, I have a bunch of drills, right? And this is just a single plate, right? At the end of the day. So, and then if you just scroll down, those are your KA blocks, so which is your all the bending operations. So all the bending operations that you see. So if your machine can execute the bending operations, so this is where those commands will kick in. But the CMS viewer can only show you on the plate level. So it cannot show you the bending operations. So as you see over here, so I can see that plate with all those drills that I have. And if I just scroll down on that, the software will show you that the CMS is not showing you all those bending operations, right? So, if your machine can execute those commands, then you're good to go. But what I'm trying to show you here is like, we can cover those both the bending operations and at the same time treating it as a simple plate and creating the Nc1 file for that plate and bringing the operations, whether it's any opening, any internal cut, or any drills or something. Okay, so I'll just work on a similar example just to show you this how easy it is. Again, it's not a closed profile anymore, as you see. This is a special profile, and then I have a bunch of opening here, and and then the process again the same thing. You open it and you click on get DSTV, so it's pretty straightforward. It gets your 4 drill that you have. It's those opening can be represented as a drill as long as it falls into definition of a drill. And you can also bring them as an opening if you want. So the software has that settings that you can always do that. So we have also post-processing. As you see, there is slots as a drill, so that's why it's bringing them as a BO. But if you don't want to bring them as a BO, if you want to bring them as an IK block, we have to uncheck it. You can do a bunch of post-processing as well. Okay. So yeah, so that's pretty straightforward to create Nc1 file from your bent profile as well. Okay. The same goes for your shape sizes as well. So let's say if you create something sheet metal, from your sheet metal, if you try to create some standard sizes, for example, let's say you want to create an angle, we can also create an angle from there as well. As just only thing that we have to do from that profile, either we have to assign it the size, the standard size have to be there, or we just use the library to assign it to a standard size. Okay, and from there it will treat it as a shape, and it will create an angle, for example, if you just make an angle from your sheet metal. Okay, so that pretty much it. That comes from the assembly side and the sheet metal side. Now I want to show you some examples. I'm going to close down all the stuff that I have here. I want to show you what happens if you have to work with non-native Inventor parts. So which is your SAT file, your step file, your IGS, and STP, that kind of stuff, right? So just to use things quickly, that's the reason why I'm just closing those members. But you don't have to close them to work on those. But I'm just going to close it. That's easy for me to demonstrate the stuff that I want to show you, gentlemen. So give me one single sec here. Things are going down. Yep. Okay, cool. So I'm just going to remove that shape also. Now I'm going to go to the folder that I want to work with. I'm going to close this one. Come back to the models that I want to convert to Nc1. So I know I kept all those over here. And right now, what I want to do, I want to create, I want to convert a step file and create Nc1 file from there. So I'll just use that sample. So I have a few examples. So one of them is step file. STP and step is going to process the same, and it will create the Nc1 file pretty quickly. So I'll just grab it and I'll try to open it with my Inventor platform. So as you see, this is an Inventor process. So you just say okay, and it will create an IPD file quickly. As you see that, it's automatically saved it as an IPD, right? So I'm just going to change this the view just to show the things correctly. So as you see, I have few drills here and there, right? And to create Nc1 file, remember, gentlemen, that I need to know that the shape size information, right? So if I just go back to the I properties, I'll be looking for the shape information on the stock number. So as you see, it's not there. Okay, but I know it's a 4x4 1/4. So let's use that one. So it could be a good way to show you the step here as well. So as you see, if you don't have it done properly on your properties, I can easily add it from here. So you just type it in and press enter from your keyboard, and the software will take it. Okay. So once this is done, so you additionally you had to give the input for your shape sizes, right? If you didn't have it there. In most cases, you will not have that information, because when you convert any step files, non-native parts, now you will lose the details, right? But if you have it, it's good. Like we can grab the detail from the shape catalog. I mean, not the shape catalog. I mean, from iProperties, and we can match it directly, right? So okay. So what we just added this shape size information, right? So once this is done, all I have to do is click on your DSTV, and that's it. And I have my whole thing ready here. As you see, I have a bunch of the BO operations. So as you see, the BO stands for drill operations. So if I just try to verify that visually, that was a tube. So I'm just going to refresh that path again and see that sample.nc1. That's the nc1 file we just created from that step file. So as you see, all those tiny drills came up. One of the things also, as you see over here, that's the character that's 4 popped up on that face there. See that that came up as an opening. So if you have anything that you don't need, this window is really editable as well. So I can, let's say, like those ones are not necessarily that we wanted. So I can just select those IQ operations. I can just delete them. I can just delete them, and I can update that Nc1 file, saving it to the working directory. Okay, so if I just save it, and if I just go back to my viewer and try to see that again, and you can see that those openings are gone. Okay, So it's pretty straightforward and pretty useful. That window is also editable. Okay, so that goes to the step file. So I'm just going to go kind of and show you the same process for an IGS file. What happens if you have an IGS file? So the process is identical. So you just grab that if it's step file or IGS, whatever it is, I'm just going to open that IGS file, and the process is identical again. So you just hit OK. As you see that, this is an example. This is a channel, and this is my this is a matrix shape. So I just want to show you this time how can you use the shape catalog. Remember, I don't have that information anymore because it's I don't think I have it right on the properties because it's a non-native part. So I'm just going to use this one just to show you how things works on the shape catalog. So I can just go to the Australian library. I know it's an Australian shape. It's a PFC, 200 PFC. I could have just type it in from there, but I just choose to do that from here. So I know it's a channel. And then as you see that, this is a 200 PFC over there, right? And you just double click there, and then the software takes it from there. And all you have to do is click on Generate DSTV, and boom, your Nc1 file is ready to go. Okay, pretty straightforward. I'm just going to show you guys one last example for non-native part, so which is a SAT file. So it's the same process again. So I'll just use that SAT file just to show you guys that, you can also we support multiple non-native standards. Okay. So I'm just going to say okay. That's a pretty straightforward I-beam, as you see. So I don't have the size again. So all I do, I add that size again. So it's an 1860. I know the size beforehand. If you don't have it, the software can be used as a search tool as well. See that over here? If you just go to the edit, come to the match, and this is, let's say if you're working on a profile I-beam. Okay, so what do you say? It's an I-beam, and you give it a parameter, for example. So let's say the height is, I don't know. Let's say, for example, it's anything that is 6 inches high, 6 inches tall, and the profile height-wise. So show me all them. Nothing. Okay, maybe this is not a profile standard. It's a profile code. That's why it didn't show me. So it lists me. It can show it all the parameters in millimeter, also in inches. Okay. The reason why I'm showing you that, gentlemen, is just to show you that you can do the search as well. To process this part that we are working with, we don't need that. I'm just using that example just to show you that the software has other capacity as well to search the size for you. If you have those parameters, height and width, and you can easily find the size that will be working for you. Okay. So it goes to you can go with a different standard as well, right? Not necessarily only the AASC standard. It could be any standard that you want to work with. Okay, so I just added the size from that my quick add. All I have to do is click on Generate DSTV to create Nc1 file. So as you see, within single click, and I have the Nc1 file. And if I just want to show those updated Nc1 file, all I have to do is refresh that path and just try to see those step files that we just converted. So that's the stat file that we converted. That's the I-beam, right? So as you see, all my details came all good. And that's, where else is that? I think this is the PFC that we worked with. That's the channel, right? 200 PFC channel. And then we had, I think, what was the other one? I think we just worked on those two. And there's the other one that's the step file, the STP file, right? So that's pretty much it. Straightforward work. You create Nc1 file from there. Okay, gentlemen. The one last thing that I want to show you is this. Our software can also work on the pipe features as well. Okay, so I just took a very sample example over here. This is a straight part with pipe profile. So all of the things that we have to make sure is any operation that I have to fall in on the faces, on the correct faces. Okay, I cannot get an operation which is not perpendicular on the plane. Okay, so anything comes up, let's say you have any opening coming from this direction, I will not be able to grab it from the pipe at this point. Okay, as long as it's 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 within a general definition of a pipe, and we will be able to grab it. Okay, so for that, I'm just going to go ahead and quickly, it's a very straightforward stuff. I'm just going to go ahead and select the custom one because I'm working on different settings and run it. As you see, at the end of the day, even though it's a pipe, you have your 4 faces, right? As I said, like, I have to have any drill operations that you have, or any opening, you have to make sure that the operations are perpendicular on those faces. Okay, and from there I can just create Nc1 file, and within few seconds there. So I think this was my pipe. Where is it again? There you go. So as you see, this is an this is a viewer thing. If you take a look on those description, those are like an HSS as a tube description, because for the machine, it's just a plane, right? And that's pretty much it. And thanks, gentlemen, for your time. Appreciate it on this. And Tanya, if you want to add something quickly.
Awesome. Thank you, Mahbub. So we'd actually like to open the floor to all of you. If you'd like to pose a question live, please do so by raising your hand now by clicking on the hand icon in the control panel. Just please also make sure that your audio is working correctly. And just a couple of housekeeping items just before any questions come through. I'd like to remind everyone that the recording of the presentation will be sent through tomorrow. As always, please feel free to share the recording with any colleagues, as well as if you'd like to set up a one-on-one demonstration or if you have any follow-up questions. We highly encourage you to reach out to our team. The contact details for our team will be provided along with the recording tomorrow. All right, I see that there's a couple of questions that came through.
Okay,
Paul?
so I'll just.
Sorry, I'm just going to go ahead and unmute Paul. All right, it shows that you're self-muted now. If you'd like to unmute yourself, you can pose a question live. Hi, Paul. It shows that you're still muted. It's self-muted. All right, while we wait for Paul, there were a couple of other questions that came through, Mahbub, through the chat. One was, can you cover how to create Nc1 files for sub-assemblies in a top-level assembly?
Well, like, well, I'm just trying to find an example that, but I'll just take that example that I worked with. So what you have to do, you have to open your sub-assemblies actually. So you cannot work on your sub-assembly directly from your assemblies. So you have to just kind of open those sub-assemblies and just work from there, just like a regular assembly. So unfortunately, you have to go to your sub-assembly level. You have to open your sub-assembly, and as long as on that sub-assembly level, you have access to your part level. What I'm trying to say is, like, you have access to your peer content, right? Your raw content, and from there you can just create Nc1 file. So you have to open your sub-assemblies manually and run your DSTV command from there. Okay, sorry, my Inventor is taking a longer time to open it, but I think that covers it. All I'm trying to say here is, like, you have to open your sub-assemblies, right? And you have to create your Nc1 file from there. So maybe I can just show you something quickly over here. So let's say for this one here, I have to open my this one, as you see over here. This is my now I have access to the component level, right? So from that, now I can run my my DSTV my entire DSTV command, right? So as you see, it failed. It's most likely I didn't have the sizes correctly. So let me go ahead and see that. So as you see, as I said, like, those are the information was not there. So, I have to have that. And then from there, if you just, there you go, see that there was an option over there that some of the plates were failed, and all those IPD were failed. So we know that, like, the software will give you a clue. So if you run it right now, so let's say, for example, I want to see only this tube, so it will pop up right now because I updated the tube. So if I run it and oh, it fails again, my bad, shouldn't be doing that. Why is it? Did I update it again? So I'm just going to verify that quickly again. HSS. There's no part name, that's why. So I'll just say H1, for example. Okay. So go back there. I'm going to say yes. So run this from here. It's failing again, but the bottom line is, like, you know, when you just have to open your sub assemblies and work from there. Okay. Tanya, next question, please.
Perfect. Here's just another quick question for you, Mahbub. What is the minimum version of Inventor that the software will work with?
I believe anything Inventor 2010 to forward, like, you know, until 2022 to Inventor 2010.
All right, perfect. And we just have one other question. This may have been shown earlier, but how does the software know where to put pop and contour marks? Are those manually added as separate objects, or are they automatically coming from connecting parts?
Yeah, you have to for the pop marks and the marking content, you have to put them that content manually. So if I just go to my first example, yeah, we did cover that, but I'm just gonna go that again. Just give me one single sec here. Seems for Inventor, and I think this my part here. Nope, not this one. Yeah. So if you just go to the modeling, as you see over here, I had a sketch line for there. So you have to have that. Unfortunately, the software will not grab that detail directly from your assemblies, right? So let's say you had it on, like, you know, on an assembly. There is no way that I can. So let me turn off this one. So there is no way I will be able to grab that detail from your how do you call it, like, you know, from your assembly detail. No, I have to have that thing and that marking content be added manually as a scribe line, as a line content, not construction line or something like this. And the pop marks, the same thing goes for the pop marks as well. You have to add them manually on a sketch level, and from there we'll be able to grab it. And you have to format it also. Not only that, you add it, and you have to also format them to our readers here. And then from there, the software will be able to convert them. But unfortunately, we will not be able to grab that detail at this point from your assembly content.
All right, perfect. Thank you. All right, well, that looks like it is a wrap for today. If there are any follow-up questions after the session has been closed, please do feel free to get in touch with us. As I mentioned before, our contact details will be provided along with the recording tomorrow. All right, I will now be ending the webinar. I just want to say a big thank you to Mahbub, and also thank you to everyone who tuned in today. All right, have a
Thanks,
great day.
everyone.